Hi class. Okay, we're ready for book review set 5, slide 2. We're going to find the product of 5,930 and 4. Product means to multiply, so we're going to take 5,930 times 4. We're going to take our ones times our ones, then our ones times our tens, then our ones times our hundreds, and our ones times our thousands, So our ones times our ones, 0 times any number is 0. Our ones times our tens, 4 times 3 is 12. Our ones times our hundreds, 4 times 9 is 30. 6 plus 1 is 37. And then our ones times our thousands, 5 times 4 is 20, plus 3 is 23. 23,720. Here we're going to show 5/12 as the sum of a unit fractions. Remember our key words. Sum means to add, unit means 1, fraction means we're going to have our same denominator there. So we are going to take unit fractions. 1/12 is a unit fraction of 5/12. Sum means to add, and we had 5 of them. That's 3, that's 4, that's 5. If our denominator is the same, we keep it the same and we add our numerators 1, 2, 3, 4, 5, and we got it right. Sum, addition, unit means 1, fraction, denominator stays the same. Here we're going to solve. 64 is 8 times as many as blank. Okay, we need our keywords. 64 is means equals. 8 times means multiply. And then we're going to put in, all right? So we have to solve for this. So let's just write it the way we like to look at it. So 8 times n equals 64. I know if I change it and put n times 8 equals 64, that's not going to help me. So I'm going to do my inverse operation, inverse opposite, inverse opposite. Inverse of multiplication is division. So I'm going to take 64 and I'm going to divide it by 8. Count by 8s with me. 8, 16, 24, 32, 40. 48, 56, 64. It's 8 times. I got a little distracted with my phone going off. So, as many times as 8 is my answer. Here, same thing. 84 means equals 7. So 84 means equals 7 times what? Same kind of thing. Set it up the way that you like to see it. It means the exact same thing. We're just moving them on either side. Okay, again, I need to do my inverse operation. Inverse means opposite. Opposite of multiplication is division. Okay, not sure if our song goes up that high, so let's go ahead and do division. 84 divided by 7 goes in 1 time. I subtract, I get 1. 1 is less than 7. I bring it down. If I bring it down, we must repeat. 7 goes into 14 2 times. 7 times 2 is 14. And it went in evenly. So my n equals 12. Oliver walks 3 miles on Monday, Tuesday, Wednesday, Thursday, and Friday. Every Monday, Tuesday, Wednesday, Thursday, Friday. He walks, so that was 3 miles. He walks 11 miles every Saturday and Sunday. How many miles will he have walked in 4 full weeks? Wow, that's a lot. So we know that every or each Monday, Tuesday, Wednesday, Thursday, and Friday, he walks 3 miles. Well, that's 5 times. 5 times during the week he walks 3 miles. And each means multiply, sometimes divide. So we're going to take 3 times 5 because every day he walks. Every Monday, Tuesday, Wednesday, Thursday, Friday, he walks 3 miles. And he does that 5 days a week. But then on Saturday and Sunday, which is 2 days, on 2 days, he walks 11 miles. Okay? But he does this for 4 weeks. So what we're going to have to do is we're going to have to find out 1 week's worth, and then we're going to have to take that number times 4 weeks. So I'm going to go like this. This means another group of parentheses. That means another group of parentheses. So that means all of this in here where I'm underlining has to be done before we say times 4. Okay, so we're going to do parentheses say, do me first. So I'm going to take 3 times 5 is 15. Then I'm going to do 2 times 11. That's 22. Again, those are in parentheses. Then I have to add them because, again, that's in that extra parentheses. So I'm going to take 15 plus 22. That's 37. And now I can multiply times 4 because he did it for 4 weeks. So I'm going to take 37 times 4. I take my 1s times my 1s, then my 1s times my 10s. That's 28. That's 12 plus 2 is 14. He walks 148 miles in 4 weeks. Wow, that's a ton. Paul had in more dollars than Daniel. Daniel had $37. Which of the following expressions describes how much money Paul had? Well, if he had more means to add. So n plus 37 to find out how much Paul had. So A is our answer. Here we're going to find the factor pairs. Remember, when we find factor pairs, I like to write all the way to 9. And I like to go 1 times the first number. Now, this is odd. 79 is odd. If it's odd, I can cross out 2, 4, 6, and 8. Okay, our 3's trick, we add our digits. That equals 16. If it is a multiple of 3, 3, 6, 9, 12, 15, 18, it's not. But if it was, then 3 would work. I know 9 doesn't work because, again, when I add my digits, it would have to equal 9, and it didn't. It equaled 16. Okay, 5 does not go into it because the ones place would have to be a 5 or a 0, and that did not work. 7, I know that 7 times 10 is 70, and I know 7 times 11 is 77. So are we going to hit 79? It'd be 2 more. We would have to be a multiple of 7, so 7's not going to work. So this is going to be a prime number. It is one of a kind, 1 times itself only. All right, let's go ahead and do it again. 1, 2, 3, 4, 5, 6, 7, 8, and 9. Make sure you take the time to do that. It only took me 9 seconds, okay? It again is odd, so I can cross off 2, 4, 6, and 8. I'm gonna add my digits, and I got 13, 3, 6, 9, 12, 15. 3 did not go in, 9 doesn't either because this would have to be a 9, and it isn't. 5 goes in though because it ends in a 5, and if it ends in a 5 or a 0, 5 will go into it. If you're not sure, do the division. Goes into 35 7 times. So it is 5 times 17. Okay. All right, let's see if 7's going. Goes in 1 time. 15, that would be 2 times. It did not go in evenly because it had a remainder, so that doesn't work. So we have 5 and 17 are our factor pairs. Let's try 4. Love my little eraser button. 1, 2, 3, 4, 5, 6, 7, 8, 9. I really could have stopped at 4 because we can't go any higher. 5 can't go into 4 because it's higher. We know 1 goes into everything. I know 2 goes into it. 2 times 2. 3 is not going to go into it because there's no other digits, and 3 or 4 is past 3. And I've already used the 4, so I stop. We're going to do it again for 36. Again, takes no time to do it. I know 1 goes into everything. I know 2 goes into it because it is even. And we're going to do quick math. Goes in once, multiply, subtract. 1 is less than 2. Bring it down. If I bring it down, we must repeat. 2 goes into 16 8 times. Goes in evenly. So 2 times 18. Let's try 3's. 3 plus 6 equals 9. 3, 6, 9. It's a multiple of 3, so it goes in. 3 times 12. I also know 9's going to go in, but I'm going to put that down here. 9 times 4 goes in. I know it's 9 because 9, when the digits are added, if it equals 9, it works. Okay, I've already got my 4 there because I just did that. 5's not going to go in because it doesn't end in a 5 or 0. Let's count by 6's. 6, 12, 18, 24, 30, 36. So I know 6 times 6 goes in. Let's count by 7. 7, 14, 21, 28, 35, 42. No. Try 8's. 8, 16, 24, 32, 40. Nope. So we have these for our factor pairs. There's a lot of